Hey everyone, thank you so much. It's a real honor to be here at the first MLOps New York. I'm extremely excited and really to think about the next direction that ML goes in our industry. And I think it really is around things like MLOps. And I'm going to cover some of why I think that's so important today. As he said, I work at Microsoft. Microsoft has an enormous amount of experience doing ML. We offer data. We obviously have our own cloud in Azure. We offer a number of advancements and models around ML. And we're really proud of that. I just came from Google. Obviously, they have a huge legacy in moving the industry forward. And Microsoft is really proud to do very similar. You can see here a number of advancements we've made over the past few years in building up our experience. In 2006, 2017, or 2016, 17, 18, 19, we continue to develop and release new models that are really the best of breed in the industry. And of course, release them to the world as open source. That is a big change from a long time ago when I was at Microsoft the first time. But it's something that we're very, very proud of, to hand all this information back. And we do use ML across all of Microsoft. It's integral to every product that you see here, basically every element, whether or not it's consumer, enterprise, and so on. We have a lot of experience going out and building models that really help us to operate our own business, and we want to help the entire industry move that direction. You can see some of the numbers that are involved here. 180 million data points in Office are monthly active users using AI services, 18 billion questions asked of Cortana, and 6.5 trillion security events are analyzed every day. These numbers are so large that we simply could not do this without services like ML. But the reality is that we, all of the major players in ML today talk about these things, and they're like, oh, these are the greatest things you've ever heard. And then someone not at these companies looks at this and says, well, geez, I'd like to do that too. 6.5 trillion, that's a really big number. I have a lot less than that. I should be able to use ML too, except, the first thing they run into is this. ML is hard. And one of the reasons is because of us as an industry. We spend so much time thinking about this. How do you build the right model? What's the area under the curve? What's the performance? And so on. But the reality is, ML is not that. That is certainly a key component to ML, but ML is about this pipeline. It's about the start to the end. It's about how do you bring in your data, how do you transform it, clean it, make sure that it's operating properly within the right confines and you're doing the right things around outliers, then training it, building your model, taking that model and bringing it out to production in the way that makes sense to you. And then you're still not done because you need to log it and monitor it. You need to make sure that it continues to perform like you expected when you first released it and feed all that information back into the original system. Now, you might say that you're a data scientist, not your concern. You really just want to focus on a model. But that's not true. The reality is that, this is from a year ago from right across the street. The average model takes, 3 weeks or so to build and get to the structure that you were hoping for. And then 11 months later, it's still not in production. And the reason is because you don't want to have things be tossed over the fence. You don't want things to be tossed out without any kind of concern about how they land and how you're actually going to productionize them. And more often than not, it's because of the chasm you see over here. You'll have a data scientist on one side who's doing her job. She's doing everything she can. She needs to do very quick iteration on the latest technologies because, hey, this model requires this, 2.0 version of TensorFlow instead of, 1.11, which I was using previously. She may choose best-of-breed tools to do bias detection or outlier detection or to normalize her overall data. She doesn't really care about management headaches. Oftentimes, she'll be operating on a private cluster or her laptop or a rig in the corner of her room. And to the best that she can, she would love unlimited scale. Every time she has to sit there and wait, a week, a month, whatever, for a model to be trained, that's going to be a bad time for her and a lot of wasted time. So she'll want as much scale as she possibly can get. On the other side, you have the SREs and the ML engineers. And they have almost the exact opposite concerns. They want to use very well-tested frameworks and tools because they need to know that those are going to be uptime, have a maximum amount of uptime. Or if not a maximum amount of uptime, at least a defined amount of uptime so that they can figure out how to distribute it and be responsible around it. They often have compliance concerns. They can't roll out arbitrary tools because they don't know what the security profile or other concerns are. They need to be able to observe those as they roll out to make sure that their monitoring tools understand what's going on. And I mentioned uptime before. But we can solve this. We can bring them together. And we can do this using experiences that we've already developed, right? You know, not too recently, there was a significant movement around what's called GitOps, where you bring Git together with developers and operations and join them together in a unified system. And the way it looks like is this. You have on one side a circle of, you know, iteration. The developer continues to iterate, 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 using common tools, understand, builds automated testing, you know, and is able to roll out into source control a known binary or a known set of code with a set of performance and profiling concerns around that particular bit of code that they have. And then the SRE and the ML engineer or excuse me, the SRE is able to pick up that information and roll it out to production. And again, they're able to provide automated testing and profiling, understanding what's going on. And that really provides velocity plus security. The developer is able to iterate very quickly, and the SRE is able to roll it out in a sensible way. So what we need is MLOps. And obviously you're here, you understand generally the concept of MLOps, but you have a very similar circle, right? On one side, you have the data scientist who's doing you know, data acquisition and understanding the business, doing iterations on her model. You have them then check that into the overall development lifecycle as a binary, as source code, just like you would with standard application processes, and then roll it out from there. And by including her in the standard in the standard software development lifecycle, you're able to reuse a lot of the core practices and components that you had already done, which is so important. What you really don't want to do is develop a brand new pipeline with all brand new mistakes. The best thing you could do is help these data scientists become part of the software development lifecycle. And if you do that, you get a whole bunch of benefits here. As I mentioned previously, observability and automation. I'll get into this quite a bit in a bit, but the ability to roll this out in a well-defined way, in an automated way, is extremely important because you're going to need to do it not just once, but many, many times over. Validation, Chris just talked about how, you know, so many times people, especially in the data science lifecycle, ignore testing. They ignore testing in software development too, make no mistake. But there's particularly bad not observing it in data science because there's so many things that are opaque, they're not explainable, and if you don't have testing, you're really not going to understand whether or not your model even works. And then that final bit is around reproducibility and auditability. You hear this over and over again, reproducibility crisis in ML. This is a real thing, and part of it is there are so many steps to the ML process that are not isolated and understood, you know, whether or not it's data cleansing or training or things like that, that can get lost. And you need to have a system that understands how to do this. And with that, you get velocity and security for ML. Now, you may say, well, this is great. I would love to have an MLOps platform, and that's true. I've worked at, you know, 2 of these companies, and I can say without question that the ML platforms that they have in place, Google, it's called TFX, MLX internally, but TFX. At Microsoft, it's called Ether. These are core systems that we use to move through machine learning in an extremely regular way, where you can share across share across groups, you can pull things in, you can do all sorts of automated things in a very reproducible way. The problem is that maybe you don't want to go work at a large company with thousands of ML engineers. You would like to build one of these on your own, and you can. I'm going to, you know, demonstrate or talk about 2 that I know really well, which is both Kubeflow and Azure Machine Learning. But you start with a system that understands how to do declarative ML pipelines. You move forward and you integrate with systems that understand how to do source control and declarative rollout and have, have a number of hooks that enable you to push us through. And then you add in your standard CI/CD systems. There are many CI/CD systems. Really, so many. If you need to go build something, let me suggest not going and building a CI/CD system. There are many good ones out there. There's other parts in the industry that need your help. Now, I'm going to take off my general MLOps thing for a second and just talk about something that I know, which is Azure Machine Learning. But every one of the things that I'm about to talk about, you're able to do on your own or using open source technology. And I'm just going to touch on them because it's so important that we cover the number of different components that go into an MLOps platform. So this is a slide I like to talk about a lot. This is a very, very common scenario across the industry. What you see on the top there is the data scientist. She's on the left-hand side, much closer to the data and the model. And on the right-hand side, you see the SRE who's rolling it out. Now, you'll excuse me, over the course of today, I'm going to talk about serving live. But in fact, there's no difference here between doing live online serving of your model and batch inference. In both cases, you need this standard declarative framework, and you need to be able to roll it out in a repeatable way. On the left-hand side, the data scientist might operate in environment number one, right? And that's where her data is. She'll want to build and train that model right next to the information because that's the fastest place to do it. It's where the data is going to be the freshest, and she's going to want to iterate on it. And then when she's done, she's going to want to check that information into a standard system like a CI/CD system and then kick off a second bit of workflow, which is the SRE's work, where the SRE is going to go take it, do training on it, or excuse me, do testing, profiling, modeling, and so on before she rolls it out to production so that she understands the performance criteria of it. Some of the components that we offer in Azure, and again, you can do these all yourself. We have a DevOps pipeline that understands ML as a first-class object, which means you can integrate your overall ML pipeline with your CI/CD system. And this means you have a whole set of first-class modeling tasks. You can roll things out based on the criteria of your model, which is extremely important. You don't want to make it generic, or you'll end up building a whole bunch of adapters for it. And things like running unit testing, sandboxing, security checking, evaluating the model, registering the model, all these have first-class hooks. Additionally, you'll want automated deployment. That's not to say it just automatically rolls out, but things that integrate with your overall identity and verification authentication system. You'll need to have model versioning and storage. This is an extremely important point that I'll get to in just a minute. But having your model be a repeatable thing that you can roll back to and things like that is extremely important, where you have all the metadata about your model recorded over time. You'll want to do model validation, again, testing, not just area under the curve, but literally whether or not it gives you a good answer to a known response. Do model profiling. Models are very complicated things. You don't know exactly what they require. Accelerators, the number of accelerators, number of CPUs, number of cores. You'll want to test them every time before you roll them out. And then, of course, rolling out with model deployment and automatically generating Swagger endpoints. All right. So that seems like a lot of work, except we go back to this slide. You don't have this. This is what happens. The model goes out, it fails in myriad ways, and the question is why? Well, let's talk about some of the common things that you get if you have MLOps, right? You get that end-to-end system where that data scientist, even if they're not SREs, are able to be integrated into the rollout process. You're able to much more quickly deliver value to users and get that lineage and auditing that you need in order to have a compliant system. So why, right? I've given you a lot of benefits, but let's talk about some of the nightmare scenarios that you can often find. And I'll talk about these at a very high level because I think a lot of you have seen this already, but there's so many of these that people tend to ignore when it comes to machine learning. And these really aren't unique to machine learning. But let's talk about how these standard software pitfalls that you might run into come into ML when they're not integrated into the software process. So let's start with, does my model actually work? Seems like a pretty straightforward problem. So I'm going to paint a scenario for you, and I've seen this happen many, many, many times. I'm happy to talk to you about all these nightmare scenarios in depth. But let's walk you through one example. So we'll start and say, like, the data scientist sits there, she explores, she pops open TensorBoard, looks awesome, area under the curve is rad, she's ready to go. She takes it, says, I want to go out to production, this seems straightforward, and bad times happen, right? And the problem is that, you know, this is a software component, just like every other one. It can impact your system in a million ways. And so this SRE is great. She's great at her job. She sees it. She sees the thing stop. She says, you know what? You already did something bad. You grabbed a pickle file and you threw it in production. That is basically as bad as you can possibly get, right? So I'm going to stop you right there. And we're going to use source control like a good group of people. And now it goes to source control. Good times. Have a record of what went out. Except, same problem. Which is not good. She's like, I'm doing what I'm supposed to do. It's got checked into production, or got checked into source control. I know. It got rolled out like a standard thing. What happened? You know, this is a small set of example of the things that can happen. And it's funny because, like, every time I show this slide, and you can be up here too, people come up and they're like, oh yeah, but you forgot this one. And I will mention you on the slide, so please come tell me. But I promise you, this is really it. Like, drivers out of version, didn't get the number of cores right, didn't have the right access to the artifact to download it to production. My certs were wrong. My permissions were wrong. My A/B testing was wrong. It rolled out too fast, rolled out too slow. Or the thing just didn't work for some God knows reason. It's 3 o'clock in the morning, and the model was supposed to be working, and it's not. And this is real. This happens all the time. Now, again, these aren't unique, right? This happens with software too. But these are a list of things that we specifically understood already do happen with ML. And so the problem is that jump, the jump from source control straight to production. Now, it sounds good, except you really need a process. And when I say process, what it means is this, right? And this is just a small example of the things that you might want to include in your overall rollout to production. But they're real, right? Maybe you want to clean and minimize. Someone checks in a Jupyter notebook. That's not appropriate. We should really compress it. We should strip out all the comments. We should build a binary. We should test it, make sure that it lints properly, so on and so forth. You'll want to have automated validation and profiling now that you've compressed this thing. You want to explain the model. You want to build an explanation. You want to test for bias. You want to test against a whole set of different data that you understand where you've run into those problems in production, bring those back, not to retrain it, but to test against real production data that you've had out there to make sure it doesn't fail. You want to package it for rollout. Maybe you throw it in a container with the right endpoints so you can do monitoring, logging against it. You can health check it, so on and so forth. And then you want to have sane deployment where you are doing exponential. You put out a canary, then you put out a 1%, 10%, 50%, and so on. And she rolls it out and everyone's happy, right? And the only way you can do this is if you have that pipeline. Now, you may say, I can do all these manually. And you, maybe, but I'm going to say no. And the reason I'm going to say no is because of this. Even if you had every data scientist trained, and you had all the tools necessary, and you made sure they all worked together, and you had a same process, and the SREs understood ML, and what the value of area under the curve is, and the modeling, and overfitting, and things like that, and, there are many, many things, you would still need a permanent, repeatable process of what you did, so that you can go back and evaluate that in the future. And that's what MLOps is. It is a definition checked in as code that you can run over and over again. All right, so that's just did my model work. We haven't even gotten to any of the good stuff yet. This is just a process that you want to put in place before you roll it out. But second, what did my customers see? So we're going to go back here, and like I said, this is online. You should apply it to your batch scenarios as well. But let's say you have this, and you have a very simple application. It's got a front end, and it's got a model server. Pretty straightforward stuff. And a customer comes along and says she'd like a loan. Sounds like a reasonable thing. And the system says no. And the customer says, okay, but why? And the SRE is now in for bad times, right? Because she doesn't know. And when she doesn't know, then these people show up. And it's not just them, right? Like, this is a joke. Certainly, lawyers are easy to make fun of. My dad's a lawyer. But honestly, it's not just this. This is how we become better as an industry. Because it could be someone being turned down for a loan, or it could be someone identified as a protected class, or it could be someone who is being turned down because they live in a particular region of the country. These are things that you have to understand in order to roll your model out. And it's not just about explainability. You'll hear that term a lot. Well, if I can just introspect the model, I can do it. But it's not, right? You need to know things like how your data trained and what did you exclude as far as outliers are concerned. What are the statistics? Do they neglect a particular population for no reason other than, you know, historic examples of bias? What did you change between your code and production? How did your model actually respond to this person? Do you have a log of that person being turned down for a loan and what happened? And MLOps can help here. So we're going to take the same thing, same model, and instead, she is going to roll it out through this explicit pipeline. Okay? So that's step one, use the pipeline. Step two is sign the pipeline. Each step in the pipeline gets a hash. That hash is signed, cryptographically secure with your particular rollout. And not just that, then you sign the entire thing. So you say, hey, you know, these are all the individual components that I signed. I'm going to record that, and then I'm going to roll that out to a immutable data store. And now, when that customer comes along and says, why didn't I get a loan? You can say, you know what? Sucks, but here you go. This is exactly what we did. Now, that doesn't absolve you of the problem. You still need to understand what's going on here. But you can say without question, when those lawyers or whoever comes along, you can say, look, this is exactly what we trained on, and we feel confident that this is unbiased. Okay, so again, you can only do that when you have an explicit declarative pipeline and a system that's built for that auditability. And finally, is my model still good? All right, so I'll tell you a little story. Here we have our SRE, ML engineer, ready to roll out a model. Inside this barn, there is an orange duck or a blue duck. What color is the duck? We're going to use ML, because ML is the best. All right, so I build an ML model, good times, and the model says it is a blue duck. So, it's a blue duck, right? Well, let's check some statistics. First, what's the population look like here? Do we know? We trained it naively. We said, well, it's probably 50-50, except it's not. There are 995 blue ducks in the world, or excuse me, yellow ducks in the world, and there are 5 blue ducks in the world, all right? But we have an extremely accurate model. This is 99% accurate, 1% false positive. Who wants to guess what the answer is here? Is it a blue duck or not a blue duck? Well, this guy knew the answer. And he came up with this equation to tell you what that answer was. And the most important part of this is that accuracy depends on the distribution of the population. So, anyone want to guess? Who thinks that the model is 99% accurate? Anyone? You guys are too smart. Oh, there's one. No. 75% accurate? 50-50? Model's wrong 2/3 of the time. It's an orange duck. Bad times. And the reason is because it was trained naively. You didn't do the analysis of the population. And then you say, well, who cares? Right? Facial recognition, pretty bad. There are not a lot of criminals in the population. And if you train without a correct assessment of the number of criminals in the population, you're going to have a bad time. You're like, oh, I'm not a criminal. Self-driving cars? How many times are there accidents? You name it. Like most of this, retail checkout, ad click-through rates, the majority of the things that we are looking for tend to be isolated incidents. And so you need to do this training with the understanding of the population. And you can't address it. So now I'm going to train a brand new model, and the model is going to be awesome, and it's going to be well aware of the population, and it's going to identify a blue duck, and it is a blue duck, so good times. Except what happens if the population changed? We had a migration, it's springtime, or fall. And now there are 500 blue ducks. but my model was trained in the exact opposite way. And so now I get a wrong answer, right? And this goes to this essence of one of the problems that we have in ML today. You need to be able to do constant retraining. Code stays valid a lot longer than models do. Data changes far more quickly. And so you need to be able to iterate very quickly. You need to watch what your inbound looks like, look for data drift versus what you expected when you trained, and then regularly or continuously retrain. Even if you don't need it, you should be training almost constantly to make sure that brand new models off of new data work. And having multiple versions to roll back to, I already talked about storing and versioning your models over time, will be extremely possible. Now, without a end-to-end declarative MLOps pipeline, this kind of stuff will just tax your team to death. And so that's why it's so important to build it. So there you go. I hope I've made a convincing case on some of the problems that I promise you will face and how MLOps can work. And so, like I said, MLOps gives you a whole bunch of stuff. Software practices for building machine learning models with repeatable workflows, an immutable record, which again you're going to want when it comes to recording exactly what you did, and really an acceleration of code to customer benefits. A brand new paper comes out, you can have your data scientists work on that model and roll it out very quickly without having to rewrite your entire pipeline. But what's next? I talked about a lot of stuff you see here. They're available in open source or from most of your major cloud providers. They'll be able to provide all the stuff you saw up here. But we're not even done. We're not even close to done. When you go and look at the largest companies and what they do for their overall MLOps pipelines, you see things like this. That simplified monitoring, retraining of your models, that should be automated. That should be fed all the way back. So you can get what's going on in production and pull that back as information. We need to extend MLOps for data prep and production. There are a number of tools, technologies out there today. Unfortunately, they're siloed off, and we need to pull them into the overall platforms. You see a number of different enterprise features. I talked about test cases already, auditing, security, resource auditability. Again, the ML is one of those workloads that will eat 100% of your compute if you don't understand how to keep it constrained. And really, and this is the last one that I will hammer at over and over again, metadata standards. Metadata schemas, metadata structures, how do we share metadata between all these various projects? Because one of the biggest problems is the hard part with building an MLOps pipeline today is not the big white boxes, but it's those black arrows that go between the boxes. How do we schematize it and make sure that these models are appropriate, or the metadata that we pass through is appropriate? Or better yet, tell us. This has been one of the greatest experiences I've ever had in launching Kubeflow just about 2 years ago. I've seen so many people from the industry come along. We're here to help. We're here to listen. If you have a particular need that we can help with, we would love to do it. And the reason I'm so excited about this is because this really is a brand new world. The people who are going to change the world are not in this room. They are the people who are subject matter experts at the areas that they particularly understand, whether or not it's housing or medicine or environment science or things like that. And it's up to the people in this room to give them the tools and the technology and the ability to go and use their subject matter expertise in ways that make sense. And with that, you can see all my contact information here. Please do reach out. I would love to help. And I have a couple minutes for questions. Anyone? Okay. Thank you very much.
Another round for David.